Cool. So as developers, it's not uncommon that we will need to create complex apps that run on multiple platforms, usually as separate apps for each platform. But honestly, that's a lot of work, especially if you keep expanding on it and maintaining. And this often requires multiple developers dedicated to each platform, unless you're just really overworking somebody. So while it's always nice to be able to come in and say, you should try building both of them from a single cross-platform tool like Flutter, life is never really that easy. So there's a good chance that you already have a fully built and market-ready app for at least one of these platforms. And the powers that be aren't going to really take too kindly if you come in saying, we should just throw all of this away and start from scratch with this other platform that I've been hearing about. So with that, I'm going to start by saying you should try building both with Flutter. Just really briefly, just so you know what Flutter is and how the tool can help you out. But rather than saying that you need to build everything completely from the ground up, I'm going to introduce a few concepts that'll hopefully be useful as you start to learn more and build things with Flutter, especially just particular components. And then after that, I'm going to shift gears into a more practical approach to how you can convert your apps in a more pragmatic way into Flutter, while still using a good chunk of your existing code and just kind of converting in iterative steps. Finally, we'll wrap up today by talking about how you can interact with platform-specific features from your app and how this works to essentially help you reuse some of your existing code with Flutter. Great, so first let's briefly talk about what Flutter even is. It looks like this is a whole Flutter track, so some of this may be redundant. I wasn't 100% sure, but it's okay. So basically, it's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms on top of C++, using a 2D engine called Skia, which happens to be the same engine for graphics and whatnot that are used by Chrome, Android, and a few other platforms. But it's all built into this one single SDK. And then since everything is actually built from a single code base, you can create your apps for multiple systems, such as Android or iOS, without all the overhead around knowing a ton about like all the individual details for each specific platform. Cool, so if you are lucky enough to have the option to build everything from the ground up, you are probably thinking at this point, why should I even consider Flutter? So there's a few key attributes that make Flutter useful and will hopefully save you some headache in the long run. So first, the framework makes it really easy to put together UI quickly that will work on Android, iOS, web, and whatever else the team adds on later. I think we actually support Mac OS now as well. I haven't actually played with it yet, though. But anyway, if you watch a few videos from I/O this year on Jetpack Compose, you'll probably even see some similarities between that and Flutter in regards to using a declarative UI strategy. So Flutter is also completely open source and has a strong community around it. So developers around the world are constantly improving the framework, creating plugins that solve for various cases and are helping others out by answering questions. So Next, Flutter also has some of the best documentation that I've seen for a tool. So you can run Flutter examples, snippets directly from their docs pages. And there's just a slew of samples that are out there to help you figure out a lot of challenges that you may face during development. And then finally, this is kind of a given for any cross-platform tool, but once you've actually built something with Flutter with multiple platforms in mind, it becomes a lot easier and therefore cheaper to maintain your code bases over time. All of these also apply to new Flutter components that are added to your existing apps, but we'll also kind of talk about that a little bit more later. So that all sounds great, but let's actually dig into how this can help you out by doing a quick overview of some of the key practical concepts behind Flutter. When you're working with Flutter, the first thing to understand is that everything is a widget, and all UI is actually described by widgets in a tree structure. So the one key term that you're going to see in Flutter documentation around this is aggressive composition, which essentially just means that aside from some very basic widgets, the widgets that you're using in your apps, either custom ones that you've put together or that come built into the platform, will be made from other widgets. So you can think of them like Lego bricks, where you just connect them together to build whatever you want. So while there are hundreds of widgets, that's not really the focus of this talk. So for the next step, I'm going to just quickly go over a Hello World example to demonstrate how widgets work, and then we can dig more into things that are relevant to interacting with the underlying device. First off, all Dart apps use the main function as their entry point, and in there you can initialize various components and start your Flutter application. You can also see a center widget in this example, which will center your content in the middle of the device screen. If you're familiar with Android development, then you can actually see that this is definitely a different strategy for laying out items on the screen rather than using some sort of container view and then setting properties through an XML file. Next up is the text widget that I'm sure you all can guess it's going to show some text, so it's not super exciting. But this text widget also has a few other properties that can be applied to it. The first one is the string that can be displayed by the text widget. And the second is a named optional property, which in this case is text direction, that can be used to customize the widget. Back to what we were just talking about with Android and XML properties or views. This comes off as a sort of middle ground where the properties for UI items are just set directly in the main code. And then all said and done, you end up with this stunning example of a beautiful, simple user interface that does pretty much nothing. Oops, I'm going backwards. There we go. So like I mentioned earlier, there are hundreds of widgets in Flutter. So to learn more about what is available to make a solid UI, I really recommend checking out the Google Developers YouTube channel to find the Widgets of the Week videos, and to check out the official widgets reference documentation at flutter.dev. Great, so let's say you've gone through Hello World and have moved on to learning how to make UIs that people will actually want to use. The next thing you'll want to do is plan out your app's UI so that it's useful for your users. So we've all seen apps made with multi-platform tools where they just don't really look quite right compared to the system standard UI, such as Android apps that look like they were designed specifically for iOS. Users don't like using apps that don't look like they were made for them, and developers don't always want to put their name on apps that just don't really exhibit best practices. So what makes Flutter handy here is that it's able to tell what platform it's being used on, so you can apply the proper UI elements for your app based on the OS. Over the next few slides, we'll go over a simple example of how you can use Flutter to make this happen with a simple slider UI widget. So first off, this functionality is available through the Dart.io package that can be imported into your Flutter app. When the user is on iOS, the platform.isIOS flag will be true. If the user is on a different OS, then that flag is just going to come through as false. You can also see that we're using a standard ternary statement here to expand the proper UI widget for whatever the platform is on. And then it's just kind of worth mentioning here. So while we're using platform.isIOS here, there's also a platform.isAndroid, and I think there's some other ones as well now. So you can kind of figure out what you're working on for your platform to give the proper UI for your users. So after you've actually checked that flag, you can expand an iOS-specific Cupertino widget to have it look like a native component when on iOS devices. So for this example, we're going to take a look at using an iOS-styled slider from the Cupertino package. One thing worth noting here too is that you'll need to make sure that you import the Cupertino Dart package into your app in order to have this styled widget. Luckily, there's just one line in a configuration file to pull this off, and then you're good to go. Now, if the user isn't on an iOS device, then you can just expand a regular slider as a part of the second option in the ternary operation. So in this case, it'll give us a slider that conforms to all the best practices for the material design component without a ton of overhead. And then finally, you can see that both of these sliders have properties that can be set on them. So while the base properties are the same in this sort of small example, there are some differences in the components, such as a background color property that only applies to the regular material slider. You'll want to check documentation or source code whenever you use a platform-specific component, just to make sure that you're actually setting the correct attributes, rather than assuming they're always going to be the same. Now, if you want to see a fully functional sample that puts all of this to use, the Flutter Gallery app is a perfect starting point. So this app is actually entirely open sourced, and it's available up on GitHub, meaning you can just go in and grab whatever functionality that you like out of it to throw into your projects. It goes over a collection of widgets that you can use with both material and Cupertino stylings, and it has a ton of other useful features that you can mess around with in this sort of playground app. And then each widget section in that gallery app includes a descriptor, and you can bring up the code that was used to create that section. Each section also has an icon at the top that will take you directly to the official documentation for the widget that you're looking at. Additionally, there's a variety of tools that can show you how to do animations, media playback, or display each of the available stock colors in Flutter to help you get your new Flutter components put together even faster. And then finally, the Gallery app also includes case studies, so you can see how common features work together in a big picture scenario, rather than just like a bunch of one-off widgets. So here you can actually see a staggered grid view, some hero animations, circular animations, different types in a single list, and a few other useful items in just the screenshots here. This is great when you're also trying to put together just a quick feature. and you get examples of animations and interactive components out of the box, rather than spending a bunch of your time just trying to go through Stack Overflow or random blog post or any other documentation just to make things that have already been solved before for you. But speaking of the documentation, as you probably noticed, I've actually mentioned it a lot already. So I'm a huge fan of what the Flutter team has already put together, especially since a lot of it isn't just that standard, this component does something sort of stuff. So one of the things they have is the Flutter Cookbook, which is a documentation page containing various code samples or recipes, which is where the name comes from, for a common task that you might want to do in Flutter. So this is just a sample of what's there, but you can see there's a lot of great content that you'll use in pretty much any app that's out there, such as animations, design elements, and networking. Using the tools that we've talked about already, you should be able to write some pretty solid Flutter components using Dart that can be integrated into your existing apps. And then the next thing I want to talk about, plugins, are essentially just a fancy word for libraries or modules, but they're one of my favorite things about Flutter. Luckily, these are available for your app anywhere that you're using Flutter, and not just in apps that are built from the ground up in Flutter. So if you're adding Flutter into like an iOS app, you'll be able to use plugins for that Flutter portion of it. So like we've talked about before, the development community is so active and passionate about the platform that they've created thousands of open source plugins that you can use in your apps to easily accomplish tasks without having to reinvent the wheel. So you can actually find most of these plugins by using pub.dev, which is a site that was created by Google for searching through plugins and finding their documentation and their source code. If you get a chance, I actually really recommend just poking around to see what plugins are available and seeing how they're doing what they're doing by looking at their source code. This will give you a ton of great functionality that you can just kind of learn from other developers and what they've done, and gives you ideas of what you can build for yourself as well. So now that we know what Flutter is and how to do some just general things with it, like creating widgets, detecting the platform, and using plugins, let's get into the next phase of this talk. This is actually where I think things get a little bit more interesting as well. So like we said before, there's a good chance that you're already working on an app. So starting from scratch just to implement some cross-platform functionality isn't always going to be a viable option. So to help with this, the Flutter team has actually put together a feature that I'm actually assuming didn't have any help from their marketing team, because it's oh so cleverly named Add to App. This will let you add entry points into Flutter components from your existing iOS or Android apps. With Add to App, you can actually stagger out your conversions to Flutter as well by writing one component at a time and then adding it to your already built apps while maintaining feature parity for your users. One thing that you should definitely know at this point too is that a lot of what we talk about in this section is still considered experimental. So it works, but there's a chance that they're going to change it over time. My guess is things aren't going to change drastically, so it shouldn't be a big deal. But just in case you're watching this in 6 months and are wondering why your code's not working, there's that chance. So for the next section, we're going to get kind of deep into some code, but I'm going to try to keep it as simple and small as I can. So you don't need to be familiar with Dart or Flutter to actually follow along. My goal here is not to overwhelm you, but rather just to let you know what you can do and to give you a bit of vocabulary and a schema to reference back to later when it is all applicable and useful for you. So this section is going to cover how we can create new Flutter screens for your apps and how you can navigate to them directly from your native Android and iOS app components. For what it's worth, I'm going to be keeping everything pretty much in the like Java and Objective-C world. I might have some Swift in there actually. I don't remember offhand. But I'm just trying to keep it as general as we can for the broader audience of people. So first, what we need to do, though, on the Flutter side of things is create a new Flutter class. So in this case, it's called My App, and it returns a new Flutter widget called My Homepage, which is what the user is going to see when they actually get to the Flutter component within your app. You'll notice that we're also accepting a color parameter in My App, which will be used for setting the app's theme. So it's worth noting that while we're just using one screen for our entry point here, you're able to create multiple entry point classes for your apps, similar to this one, that each are going to do their own different things depending on what your app is going to require. After we've created our Flutter widgets, we'll need to define entry points that we'll use from our traditional app in order to access the new Flutter screens. And then since we actually set My App to accept a new color parameter, we can use that to configure each entry point to pass a very specific color into our new Flutter widget to illustrate how each endpoint works. That way we're not just saying, oh, look, the same exact screen is being gotten to from 3 different areas. and they'll each very specifically have a different theme to them. We also have the main function that our component will default to if a specific entry point isn't declared. So in this case, the default is just going to be the orange themed, essentially hello world screen that we're going to look at. And then that's it for the Flutter part of it. Everything else after this is going to be on the native side of things. So obviously in a real world situation, you would expand on returning widgets to match your use cases rather than this sort of idealized sort of example, but the general concept of Flutter entry points is going to stay the same. Next up, you'll need to actually access those Flutter endpoints from your existing apps. So we'll start by seeing how you can do this from the Android side of things. So here we have a pretty standard Android application class. In there, you're going to want to define and initialize a new Flutter engine group to store and access each entry point. This Flutter engine group is just going to be a collection of Flutter engines, which themselves are execution environments that are used for bridging between your native mobile code over to Flutter. So the Flutter engine group and Flutter engine itself is kind of super complex under the hood. Basically by using these classes, it abstracts it a lot for you. If you are interested in this stuff, though, I really recommend digging into how they work with this, because I think it's just one of the cooler parts of Flutter. But anyway, moving on to the next part here. Next, we can actually write a new class that creates and binds each engine and entry point into that existing Flutter engine group. So this is done by using a Dart executor to find the entry point and then bind it to within a new engine. So while this engine binding class isn't already provided for you by Flutter or any other library that I'm aware of, it does do the job of demonstrating the process. And I'm sure anyone out there can do a way better job than I can of architecting this. If you do, make it a plugin. We'll kind of talk about that a little bit later as well. So once you have the engine binding class from that last slide built, it can be called at runtime whenever each entry point is actually needed. So it's actually lazy loaded, which is pretty nice. So for this example, we're going to create a Flutter activity class that will act as our bridge between our Android and Flutter layers. And then it will have the scaffolding necessary to call any of our Flutter entry points, again, by lazy loading them, the Flutter engines when necessary. So the provide Flutter engine method is actually called as soon as our new Flutter activity is started. And then by retrieving a value passed to our activity, we'll get this all through the current intent. And then we can decide which binding we'll want to use and then start up that Flutter entry point from our native Android application by returning the appropriate engine that we bound earlier. So in this case, we're going to say we want the bottom main one, and then it's going to return whichever one we actually called bottom main with whatever color we're using. So I'm going to just scroll back for a second here. So bottom main is actually this one that has the purple coloring. You'll see why they're called top main and bottom main. I was actually running two of these on the same screen for a while, and then I made them their own entry points. But again, it's just going to be starting up the purple one using that entry point. Cool. And then finally, we just need to launch the Flutter activity. So this is going to be done like any other activity in Android. So you're just going to need to create the intent for that activity, add whatever extra values you need for it to be able to work properly with your logic flow. And then that's going to be extracted by the Flutter activity that we had just shown. And then it'll pick the proper engine and then call start activity with that intent to launch the screen. So here we can actually see an example of just 3 buttons in a native Android app. And they're each going to be able to launch one of the 3 Flutter entry points that we had just shown. And then since each individual entry point has been associated with a specific color, we can see how each button can launch its own unique Flutter component. So I think we said there was, what was it, orange, purple, and green maybe? Anyway, so we can see just kind of what that's going to look like by clicking these buttons and launching them. Cool. So there's also a good chance, I feel like this is actually super common, that you've already worked on an iOS app first and have kind of had Android as a second thought, which is unfortunate, but it's the way things tend to work. So I want to go over how that's going to work for adding Flutter into your own iOS apps. Essentially, this is going to be a very similar process, but we'll see how it works. So just like we did with Android, we'll need to create a new Flutter engine group. This will be done from the iOS app delegate, which is essentially like the Android application class, if you're familiar with iOS or Android. So from the delegates init method, we'll need to create a new view controller that'll act as the bridge between the iOS app and the Flutter framework. So you can think of this as analogous to the Flutter activity that we'd put together for Android. This engine will accept a string that can be used to select the Flutter endpoint that you'll use when showing your new Flutter screens. And then actually, if you want to show multiple Flutter view controllers on the same screen, then you can actually just initialize two separate Flutter view controllers with the appropriate string parameter. So this is actually what I was talking about earlier with the top main and bottom main. And that's because we're going to show two different view controllers on the same screen, which I didn't do on the Android side, but I did add it to the iOS side just to kind of show how this will work. And then finally, you're just going to need to add any new sub view controllers that we'd created into our currently displayed view controller. And then from that point, we can also modify any properties that are associated with our sub view controllers to do things like split each of the Flutter UI components across different portions of the screen. So here you can see an iOS app that's going to launch both a single Flutter screen and a new view controller that has two separate Flutter pages embedded into it. Now, actually, there's one thing that's worth catching here too that we're going to talk about in the next section. But if we click on the counter button, then any of the Flutter or iOS screens, like if we click it on either of those, the number that gets incremented is going to remain consistent across the app. So this is actually done using something called platform channels. So platform channels are a way that you can call native methods in iOS or Android code directly from Flutter, as well as a way to pass data back and forth between both layers. While add to app is focused more on calling Flutter code from the native level, platform channels are bidirectional, but to keep things simple, we're just going to focus on them from the Flutter layer over to the native perspective. So the first thing we need to do to use either type of platform channel is to set our channels through the Flutter side of the app. Event channels will let you communicate between your Flutter components and native components using asynchronous event streams. And the method channel will let you call native platform methods from the Flutter framework. So for the example in this talk, we're going to create a method channel that will let us request the device's current battery level. And then we're going to create an event channel that will let us know whenever the device's charging state has changed, such as a phone being plugged in or unplugged. Well, both of these examples are going to be focused on sort of this power, hardware, and event setup. You can actually use the same concepts, though, for any sort of library or functionality that you've already made natively for iOS or Android, and able to make them work for your Flutter components. So the big use case that we've been seeing with this is, say you work for a company that has 100 internal iOS apps, but no Android apps. So if you have a lot of common code between them, rather than having to rewrite everything for Android and then having to maintain two separate code bases, you'd be able to add kind of this event bus layer between it, and then you just have to write the same libraries in Android, which you would have had to do anyway, but then you get Flutter for the UI component side of it, just to make things a lot easier to maintain and kind of consolidates things a bit. So after defining our event channel, you can attach a listener that'll respond to any broadcast events from that platform. And in this listener, we have an onEvent and an onError method. In onEvent, we can check the event type to see if it's the charging event that we're trying to catch, and then we can respond accordingly. Of course, you'd be able to use essentially any kind of event that you would expect here. This is just a standard event bus where you want to check to see what the type is, and then make your decisions based off of that. So in this case, we're just going to change some text on the screen by saving a new string, and then setting the state in Flutter. We'll do something very similar in onError for our use case, but generally this is where you will want to handle a situation where something went wrong in whatever scenarios you're supporting. Finally, we're going to want to implement our method channel from the Flutter side. So we can do this by creating a new function from our Flutter code that will request the battery level from the underlying platform and then return it. Here you can see we're invoking the get battery level native mobile method on whatever platform we're using directly through the method channel that we created earlier. So this is back on the Flutter side here. Once that result is returned to us, we can actually save the result and then call setState to update our Flutter UI. So with that groundwork done on the Flutter side of the app, we'll actually dig into how Android can use both the event channel and method channel to work with the platform-specific components. So just like we did in Flutter, we need to state the name of the channels that we'll be using. So as you might have guessed at this point, you can actually set up multiple channels specifically for each task that you're trying to support. So for this example, we'll just do everything pretty much in our main activity, but this can apply to any library code or other activities that you might be using. Once the channels are established through the Flutter side of things, you can start using them from our native Android app components. So let's start actually with the event channel by creating a new event channel object. From there, we can create a new stream handler and set it onto the event channel. Next, we'll declare a new broadcast receiver named Charging State Change Receiver, which is a very bland but descriptive name. And then we're going to initialize it a little later using a separate method. After that broadcast receiver is created, we just need to register it through the register receiver method that we have, and then actually have it listened specifically for the action battery changed event, which should just be native to the Android system. When that event is received, it'll be put onto the event stream and then sent back to the Flutter layer through our now established event channel. You'll also want to make sure that you unregister any receivers through onCancel when it's time to actually tear down your event channels, so you don't end up with any kind of weird memory leaks or unexpected app behavior later, which trying to debug that is a nightmare in any situation. So just kind of worth making sure you catch that early. And then as for our broadcast receiver that we used on the last slide, it's just going to be some regular Android code. So we'll actually use this method to create our new broadcast receiver and then pass in our event bus. Anytime that receiver is going to receive a charging event from the system, it'll extract the status from the broadcast intent and then check to see if it's in an error state. If it is, then we're just going to go ahead and throw an error onto the event channel so that the app can handle it appropriately. But if everything looks good, which we're hoping is pretty much every time, then we can just check the status of the event to see if the battery is full, charging, or discharging, and then post that over to our Flutter component. And that's all it takes really to listen for events, for charge event changes on Android, and then to be able to actually send them over the event channel to that Flutter component. So here you can actually see an example where we're manually changing the charging state on an Android emulator to go ahead and trigger these events. If you were just using this on a physical device, you would just plug it in and unplug it. So what's nice about this is that it's actually not restricted to broadcast receivers, but really any kind of event-driven action in your app can be linked up to an event channel. So if you're using something like coroutine or RX, then you're pretty much a step closer to being able to use Flutter relatively easily within your existing Android apps. So as for method channels, we can return to our Android activity and add our own new method channel object, which itself is going to contain this new method call handler. When a method call from Flutter is received on the Android method channel, onMethodCall is going to be triggered. From there, you can check the string that gets passed in with a method call to see which method you want to use, and then we can respond accordingly. Once we have our results from the native method call, we can return it over the method channel. I say method way too many times here. Send it over to our Flutter component as a success, or we can just send it back as an error message if it's appropriate. However, if the method that we had actually requested is not implemented, then we can catch that error case and then return a not implemented message back over that channel. And then as for the get battery level method that we're calling from our handler, it's just another plain old Android code setup to request the battery level directly from the Android platform. So it can be returned back over as a result over the Flutter to the Flutter layer. So while this example is relatively straightforward, you can actually use the same concept here to integrate your existing code and custom libraries into your new Flutter components without having to rewrite them entirely in Dart. And then for good measure, back to our emulator, you can see that we actually have that Android method channel at work by basically changing the battery level in our emulator, and then we just click the button to request what that battery level is, and then we display it as a string on the screen. So here you can see it says 60, and then up to 50%, and then what is that, 57, and I kind of just throw it all over the place. And one more thing before we switch over to the iOS side of using platform channels. One thing I did want to mention is that communication, for whatever reason, does need to happen on Android's main thread. So this means that you'll want to be mindful of what you're doing on both sides of the channel to make sure you're not doing background operations on the main thread or trying to update UI elements from a background thread. Android's pretty good at catching this when it happens and then yelling at you by crashing. But it's just something to be aware of. And then to wrap this up, I'm just going to go over how this all works from the iOS side of things. So generally, again, it's going to be similar, but there are a couple nuances that are worth mentioning. So we'll start with the method channel this time. The first thing we'll need to do is declare our method channel by the name that we're using in Flutter. After that, we can attach our method call handler to the new method channel. And then when this handler receives a message, we can check to see if it's our get battery level request. If it is, then we can attempt to get the battery level from the device so we can return it back to over the channel. Otherwise, we can just return an error message. Again, if the method that we have requested doesn't exist, then we can just return a not implemented response to our Flutter layer. As for the iOS version of the get battery level method, we're just going to treat it like we did on Android. We're just going to use regular native code to essentially find that level and then return it over the method channel to whoever was calling it. And then our setup for the Flutter event channel is done pretty similar to how we did it on Android as well. They're really good at keeping this pretty much on par. So one developer can come through and kind of figure it out. So we'll first create the new event channel with a name that's going to match the channel on the Flutter side of the app. And then we'll associate a new stream handler with it. After that, we're going to need to make sure that we implement the onListen with arguments method so that we can pass in and save anything from our, or so we can actually save our Flutter event sync. Then we're going to add an event listener for battery state changes that then sends the information to a new custom method called sendBatteryStateEvent. Next, we're going to check the state of the event that was sent to the sendBatteryStateEvent method. And then finally, we'll funnel those system events through our event channel and up to our Flutter platform code using the linked event state. And then again, just to mention, the same exact issue that we ran into with threads on the Android side, you're going to see on the iOS side. So you're going to want to make sure that any communication is going to happen on the main thread in iOS, just so you don't run into any weird threading issues and whatnot. So now that we know that how to use these event channels, another thing to be aware of is that only certain types of data can flow between your native components and the Flutter platform. So while there's a lot that you can do here, such as passing over maps and dictionaries alongside your more primitive types, you're still not going to be able to send over non-parsable custom objects. So while this is somewhat cumbersome when trying to convert existing native libraries so they can be used with Flutter, it's still super workable. But you do need to be aware of this limitation that you might run into, just so it doesn't catch you off guard when you're actually architecting everything. And then I actually wanted to wrap up today by saying that I would also really highly recommend that you consider publishing your own plugins if you start making some of them for your own apps. So like I mentioned earlier, Flutter is really where it is now due to the awesome community that's around it and all of their open source contributions. So once in a while, or actually once you know how Flutter and native level bridging works, it becomes a lot easier to create or contribute to advanced plugins that keep this really all moving forward and making other developers' lives easier. So first off, I guess we should start by saying, I guess what a plugin package is compared to just some regular old Dart code. So plugin packages are specialized versions of Dart packages that contain an API written to interact with one or more platform-specific implementations. For example, if you had an existing Bluetooth library written for Android, you can write a Dart package or plugin package to access it from your Flutter code, and then you could just put together an iOS implementation that can also be accessed from that same package to support both platforms' native components with a single Dart entry point. Once you're ready to actually create a plugin, you can start this whole process off by running this Flutter command. This will create some template files for you, including a unit test file for your plugin package, a default Dart file that can move your code into, a README and a changelog, and a few other general things that you'll need for publishing. And then with your template ready to go, it's time to actually do the implementation work. So you can just copy over your existing library and Dart implementations and do a few other configuration steps to get things ready to go from this point. There's a few steps involved, so this is actually kind of out of the scope for this talk. But you can find all of this on the Flutter official documentation that'll walk you through every individual step that you need to do to make this happen. Finally, you're going to want to make sure that you have some solid documentation ready to go so that others can use your plugin. Then you can move everything online by using Flutter Pub Publish to make your new plugin available for other developers. I will say though that if you want to make sure that you're going to want to make sure that you're really ready to publish before you run this command. So there's actually this dry run aspect that you can try as well, just to make sure things line up. So once the plugin is available online, it can't be removed. Like, we have no access at Google. You can't do it yourself. It exists. So just be kind of aware of that. And then, yeah, the other thing that you can notice with this dry run command as well is that it's going to make sure that you pass all of your automated tests and other analysis before it even attempts to publish. That way you're hopefully not pushing more broken stuff up there. So we briefly covered a lot of ground today. We started off this talk by introducing Flutter and why you should even consider it for your cross-platform apps. We then moved into a quick overview of Flutter widgets, what they are, and where you can learn more about them and Flutter in general. After that, we introduced the idea of Flutter plugins and how you can add third-party code into your app to achieve goals without having to rewrite everything from scratch. With all the intro topics out of the way, we dug into the whole platform migration process by talking about using add to app for, adding Flutter to your apps. And from there, we discussed event channels for sending data back and forth between the different layers within your applications, as well as how to call methods across those layers by using method channels. Finally, we did a quick overview of how you can take what you learned and build for cross-platform development with Flutter and share it with the rest of the developer community by publishing your own plugins. So overall, I hope this talk was useful for you all and gives you some insight into the practical ways that you can build apps for multiple platforms using the tools that are provided with Flutter. Again, my name is Ruiz. I can post these slides up on Twitter, or you can email me for them, or whatever you want to do there. I'm around for a couple minutes too. We can do questions here, I think. And if not, you can either get a hold of me on Twitter or through my email. Cool. So thank you.